Hey everyone, welcome back to the Wood Gasifier Builders Workshop. Today I'd like to talk to you about air jets. Air jets are a critical component to your gasifier regardless of the design. The air jet is where the air comes into the combustion chamber and that's where the highest temperatures are reached. So it's pretty critical that we have a good quality air jet to be able to provide sufficient amount of air into the combustion area. Now, we can debate about the number of air jets that's optimum. You could have 4, 6, 8, or 10, but there's no questioning the importance of the air jet to your gasifier and its operation. So when we look at the Peterson design, I want to look at the air jet. His air jet is made out of a 304 stainless, a 1 1/4 inch round bar, and it's got CNC 2 flat size, so you could put a wrench on it, and then it's got a 1/2 inch standard pipe thread. This was what he uses in his book, in his original design. It's basically drilled out at about just slightly under 3/8 of an inch. It's like 0.35. So this is what he includes in his book for the air jet. So one of the first things that we noticed about and then at the end of the book, he talks about his enhancements, and then what he says is that if you want to enhance this air jet, you can turn it into what he's calling a Venturi air jet, and basically opening up, drilling out the back side of it, open it up to a 1/2 inch, down to about 1/4 inch of where the air goes out. And what this does, this process allows more air coming into the system, and it creates pressure of the air coming out the nozzle. This is very similar to, if you had a garden hose with water coming out of it and you put your thumb over the end of it, you're restricting the opening. There's going to add pressure, and then that water is going to come out at a higher pressure. So it's the same kind of concept, and he's referring to that as the Venturi concept, or the Venturi air jet. So what we quickly found out when we were doing it was that rather than start with his basic air jet and then have to manually come in here and drill it out to turn it into a Venturi air jet, we decided there's a lot of hours wasted in doing that. This will add many hours to your build time, and it'll put a lot of wear and tear on your drill bits, drilling out a stainless steel 304 round bar. So what we did was we took that same dimension of the air jet, but since we had to have them CNC'd anyways, we just had the 1/2 inch opening already drilled in during the CNC process. So this is the air jet that we've been using in our kits and selling these separately. These work fine. It's a good quality air jet. It's got a lot of metal here, so it can handle the heat in the combustion chamber. But there's been a couple issues about this air jet that's always bugged me. One is why it seems kind of arbitrary to just basically do 2 flat size. It doesn't fit a standard socket. And you really can't use a crescent wrench when you're putting it inside. So what we ended up having to do was make our own little tool. This one's cut out of a piece of pipe. We also have done it where we cut out a chunk out of a socket, and then we put this on it, and we basically made a little tool. And that works, but most people aren't going to want to have to make a special tool just to utilize the air jet. So it didn't seem like it was a good thing to do. And then the second thing is the size, the length of the threaded side. It's not very long. You see, it's got maybe 1/4 of an inch there. So there's not much you can do. You can basically screw this in, but you really don't have much play as to how much, if you really want to control the diameter between the jets. So what I'm talking about here is this is what we're calling is the air jacket. And what we have is we have half couplers that are welded on the outside through the holes, and then the air jacket goes through the hole and screws into these half couplers. Okay, so in this case, I've got this is an 8-jet hearth, so you can see these will be welded on the back, and then the air jets would be threaded in the front. If I look inside, you can see here where the air jets are. Now in this one, I've got the air jacket liner here, which in this case it's mild steel, and then I put a stainless steel liner inside, and then you can see I've insulated between the two, so we have good heat retention right here in the hearth area, and then this is where the air jet comes through. So you see the air jet itself only protrudes, out maybe 1/4 of an inch outside of this hearth area. So one of the things that you may want to do when you're optimizing your system is to control the space or the diameter between the air jets. And to do this, it would depend how far in that you screwed in. And in this design, you really don't have much play. If you wanted to change that diameter in between the air jets, there's not a lot of thread there to work with. So what we've done here recently is we decided to change the air jet. We went to, instead of just doing a round stock, we decided to go to a hex stock. So we went to 1 1/8 inch hex stock. So now we can just use a standard socket over this. It makes it much easier to work with. And then the second thing we did was we extended the length of the threads. You can see here we extended those threads out about another 1/4 inch. So what that does is it gives us the ability now, if we want to change the diameter between the air jets and control that, there's a table in the Peterson book that talks about the dimension between the air jets. And if you're using smaller engines, you can have a smaller diameter. If you're using a bigger engine, you can have a... So basically it ranges from about 8 to 9 inches between tip to tip in here. Now with this air jet, I can get that. I can basically screw these all the way in, and I'll get about 9 inches between tip to tip, or I can let it out and put spacers in here. I can get spacers to put in here, washers or just spacers that you can buy, and I can actually affect that distance down all the way down to about 8 or a little bit, maybe 7 3/4 inch. So now I've got more flexibility in the air jet of that diameter, and then the air jet itself is beefier, right? There's more material. I didn't take off material like I did on here. I had to remove material. In this case, I'm using the full stock, so I've got much more material. It's got good heat retention. It's going to work really well in that hearth area that's going to reach in excess of 2,000 degrees. So anyways, I just wanted to kind of show you that. Oh, and the last thing is we still have it opened up in the back to a 1/2 inch going down to the front, coming out at 0.35. But rather than coming in with a straight drill, what we did in this is we have a taper. So now this goes from a smooth taper down from a 1/2 inch down to the 3.35. So now it's going to give us a little bit more of the Venturi effect. It's going to be a little bit more efficient air jet, and it's going to work a little bit better. So we're going to be moving to this. This is our latest and greatest air jet. These are going to be included in our kits, and we'll also sell these separately if you want to use them in your own gasifier design. So anyways, I just wanted to kind of show that. We're pretty pleased with this. We just got these back from our CNC shop, and these are going to work. Just another enhancement that we're working on for the gasifier. So thanks again for tuning in. Good luck on your build, and we'll see you guys on the next one.